Good day, learners! Welcome back to General Mathematics Learn by Video series. This is brought to you by QuexBook Smart Mobile Learning and PerkDC Learn Hub. I am Engineer Rex Jason Agustin, and we are now on the third part of Introduction to Functions. We are still under Part 1, Functions and their Graphs, on the topic Introduction to Functions. Our targeted most essential learning competency given to us by Department of Education for this session is performs addition, subtraction, multiplication, division, and composition of function. Our topic outline would be first, addition and subtraction of functions. Next, multiplication and division of functions. And last, we're going to have composition of functions. In line with our MELC, our learning objectives are to review the operations on algebraic expressions, to perform addition, subtraction, multiplication, and division of functions, and to simplify and evaluate function compositions. Let us review our operations on algebraic expressions. Addition and subtraction. In adding and subtracting algebraic expressions, we should take note of these following steps. Number 1, find the least common denominator or LCD of both fractions. Number 2, rewrite the fractions as equivalent fractions with the same LCD. Number 3, the LCD will be the denominator of the resulting fraction. And number 4, the sum or difference of the numerators will be the numerator of the resulting fraction. Example number 1. Find the sum of 2/5 and 1/4. Noting that the denominators are 5 and 4, the LCD or least common denominator of the fractions is 20. We can write 2/5 plus 1/4 be equal to 8 over 20 plus 5 over 20. 2/5 is equal to 8 over 20 and 1/4 is equal to 5 over 20. Next, we just need to copy the common denominator 20 and add the numerators 8 plus 5. 8 plus 5 is equal to 13 and our denominator is 20. Our final answer is 13 over 20. Example number 2. Find the sum of 1 over x minus 2 and 2 over x plus 1. For our solution, noting that our denominators are x minus 2 and x plus 1, the LCD of the fraction is x minus 2 times x plus 1 or x squared minus x minus 2. We can write 1 over x minus 2 plus 2 over x plus 1 to be equal to x plus 1 over x squared minus x minus 2 plus 2 times x minus 2 over x squared minus x minus 2. 1 over x minus 2 is equal to x plus 1 over x squared minus x minus 2, and 2 over x plus 1 is equal to 2 times x minus 2 over x squared minus 2. Next, we just need to copy the common denominator, which is x squared minus x minus 2, and add the numerators, x plus 1 plus 2 times quantity x minus 2. Distributing 2 in 2 times quantity x minus 2 will make our numerator x plus 1 plus 2x minus 4. Simplifying the numerator, we will get 3x minus 3. And our denominator is still x squared minus x minus 2. Our final answer is 3x minus 3 over x squared minus x minus 2. Okay? Let us now review multiplication on algebraic expression. In multiplying algebraic expression, we should also take note of these following steps. Number 1, Rewrite the numerator and denominator in terms of its prime factors. Number 2, common factors in the numerator and denominator can be simplified as 1. This is often called cancellation. Number 3, multiply the numerators together to get the new numerator. Number 4, multiply the denominators together to get the new denominator. Example number 3. Find the product of 4 over 21 and 15 over 8. For our solution, we will write 4 over 21 times 15 over 8 to be equal to 2 times 2 over 3 times 7 times 3 times 5 over 2 times 2 times 2. 4 is equal to 2 times 2, 21 is equal to 3 times 7, 15 is equal to 3 times 5, and 8 is equal to 2 times 2 times 2. Now, we can cancel the factors that are common in numerator and denominator. We can cancel 2 and 2 in the numerator and denominator. We can cancel another 2 in the numerator and another 1 in the denominator. We can cancel 3 and 3, and that leaves us with the answer 5 on the numerator and 7 times 2 in the denominator. Simplifying 7 times 2, our final answer would be 5 over 14. Example number 4. Find the product of x squared minus 5x plus 6 over x squared minus 3x minus 10 and x squared minus 4x minus 5 over x squared minus x minus 2. For our solution, we can write x squared minus 5x plus 6 over x squared minus 3x minus 10 times x squared minus 4x minus 5 over x squared minus x minus 2 to be equal to x minus 2 times x minus 3 over x minus 5 times x plus 2 times x plus 1 times x minus 5 over x minus 2 times x plus 1. X squared minus 5x plus 6 can be factored as x minus 2 times x minus 3. X squared minus 3x minus 10 can be factored as x minus 5 times x plus 2. X squared minus 4x plus 5 can be factored as x minus 1 times x minus 5. And x squared minus x minus 2 can be factored as x minus 2 times x plus 1. Now, we can cancel the common factors in the numerator and the denominator. We can cancel x minus 2 and x minus 2. We can cancel x plus 1 and x plus 1, and x minus 5 and x minus 5. So our answer would be x minus 3 over x plus 2. That is our final answer. Next, let us review division on algebraic expression. To divide two fractions or rational expressions, simply multiply the dividend with the reciprocal of the divisor. Example number 5. Divide 2x squared plus x minus 6 over 2x squared plus x minus 10 by 2x squared minus x minus 3 over x squared minus x minus 2. Our solution would be 2x squared plus x minus 6 over 2x squared plus x minus 10 divided by 2x squared minus x minus 3 over x squared minus x minus 2 is equal to 2x squared plus x minus 6 over 2x squared plus x minus 10 times the reciprocal of our divisor, x squared minus x minus 2 over 2x squared minus x minus 3. Next, 2x squared plus x minus 6 can be factored as 2x minus 3 times x plus 2. 2x squared plus x minus 10 can be factored as 2x plus 5 times x minus 2. X squared minus x minus 2 can be factored as x minus 2 times x plus 1. And 2x squared minus x minus 3 can be factored as 2x minus 3 times x plus 1. Let us cancel the common factors. 2x minus 3 cancel. 2x minus 3 cancel. We can cancel x minus 2 and cancel x minus 2 and cancel x plus 1 and cancel x plus 1. That leaves us with our answer, x plus 2 over 2x plus 5. This is our final answer. Okay? Let us now go to operations on functions. Let f and g be functions. Their sum, f plus g, is the function denoted by f plus g of x, which is equal to f of x plus g of x. Their difference, f minus g, is the function denoted by f minus g of x, which is equal to f of x minus g of x. Their product, f times g, is the function denoted by f times g of x, which is equal to f of x times g of x. And their quotient, f over g, is the function denoted by f over g of x, which is equal to f of x divided by g of x, excluding values of x where g of x will be equal to 0. Example number 6. If f of x is equal to 2x minus 3 and p of x is equal to x plus 5, determine letter A, f plus p of x, letter B, f minus p of x, letter C, f times p of x, and letter D, f divided by p of x. Our solution would be for letter A, f plus p of x is equal to 2x minus 3, that is our f of x, 2x minus 3, plus x plus 5, that is our p of x, x plus 5. 2x plus x is equal to 3x. Negative 3 plus 5 is equal to 2. F plus p of x is equal to 3x plus 2. Next, letter B, f minus p of x is equal to 2x minus 3, that is our f of x, minus x plus 5, which is our p of x. Just don't forget to put a parenthesis here to avoid errors. Distributing the negative sign, our solution would be 2x minus 3 minus x minus 5. 2x minus x, that would be x, and negative 3 minus 5 equals negative 8. F minus p of x is equal to x minus 8. Next, for letter C, f times p of x is equal to 2x minus 3 times x plus 5. Okay, doing the FOIL method, 2x times x is equal to 2x squared. 2x times 5 is equal to 10x. Negative 3 times x is equal to negative 3x. Negative 3 times 5 equals negative 15. Simplifying this one, our answer would be 2x squared plus 7x minus 15. That is our f times p of x. Next, letter D, f divided by p of x is equal to 2x minus 3 over x plus 5. The numerator is our f of x, 2x minus 3, and the denominator is our p of x, x plus 5. This is already our final answer for f over p of x. Alright? Example number 7. If h of x is equal to 4x over x plus 5 and g of x is equal to 2 over x plus 3, determine h minus g of x. Our solution would be h minus g of x is equal to 4x over x plus 5 minus 2 over x plus 3. Noting that the denominators are x plus 5 and x plus 3, the LCD of the fractions is x plus 5 times x plus 3, or x squared plus 8x plus 15. We can write h minus g of x to be equal to 4x times x plus 3 over x squared plus 8x plus 15 minus 2 times x plus 5 over x squared plus 8x plus 15. 4x over x plus 5 is just equal to 4x times x plus 3 over x squared plus 8x plus 15, and 2 over x plus 3 is equal to 2 times x plus 5 over x squared plus 8x plus 15. Next, we just copy the common denominator, x squared plus 8x plus 15, and subtract the numerators. 4x times x plus 3 minus 2 times x plus 5. Distributing 4x and negative 2, the numerator would be 4x squared plus 12x minus 2x minus 10. And simplifying further, 12x minus 2x is equal to 10x. Our final answer would be 4x squared plus 10x minus 10 over x squared plus 8x plus 15. Okay. Example number 8. If p of x is equal to 2x cubed minus x squared minus 5x minus 2 over 2x squared minus 5x plus 2, and q of x is equal to 2x squared minus 5x minus 3 over 2x minus 1, determine p divided by q of x. The solution for this one would be p divided by q of x is equal to 2x cubed minus x squared minus 5x minus 2 over 2x squared minus 5x plus 2 divided by 2x squared minus 5x minus 3 over 2x minus 1. This can be written as 2x cubed minus x squared minus 5x minus 2 over 2x squared minus 5x plus 2 times 2x minus 1 over 2x squared minus 5x minus 3. This is the reciprocal of our divisor. Okay? Next, 2x cubed minus x squared minus 5x minus 2 can be factored as 2x plus 1 times x plus 1 times x minus 2. 2x squared minus 5x plus 2 can be factored as 2x minus 1 times x minus 2. And 2x squared minus 5x minus 3 can also be factored as 2x plus 1 times x minus 3. Now, we can cancel the common factors. We can cancel 2x plus 1 and cancel 2x plus 1. We can cancel x minus 2 and x minus 2. We can cancel 2x minus 1 and 2x minus 1, which leaves us with our final answer, x plus 1 over x minus 3. P divided by q of x is equal to x plus 1 over x minus 3. Alright? Let us now go to the next topic, composition of functions. Let f and g be functions. The composite function denoted by f of g is equal to f of g of x. The process of obtaining a composite function is called function composition. We should note that f of g is not the same as f times g of x. They are two different things. F of g is equal to f of g of x, while f times g of x is equal to f of x times g of x. In composite function, we are using a small hollow circle, while in multiplication, we are using a small solid dot. Okay? Also, f of g is not the same as g of f. They are different. F of g is equal to f of g of x. G of x is inside f, while g of f is equal to g of f of x. F of x is inside the function g. We will explain this later through examples. Example number 9. If f of x is equal to 3x minus 4 and g of x is equal to x squared minus 3, determine a, f of g, and b, g of f. The solution would be for letter A, f of g is equal to f of g of x. G of x is inside the function f. And we know that g of x is equal to x squared minus 3. So we can say that f of g of x is the same as f of x squared minus 3. Then, we just need to plug in x squared minus 3 in f of x equals 3x minus 4. So we will replace x here with x squared minus 3. That would be 3 times x squared minus 3 minus 4. Distributing 3, that would be 3x squared minus 9. And then we still have minus 4. Simplifying further, our answer would be 3x squared minus 13. That is f of g. Next, for letter B, g of f, that is equal to g of f of x. F of x is inside the function g. And we know that f of x is equal to 3x minus 4. So we can say that g of f of x is just the same as g of 3x minus 4. Then next, we just need to plug 3x minus 4 in x squared minus 3. Okay? We will replace this with 3x minus 4. And that would be 3x minus 4 squared. It is squared in here, minus 3. So we have here minus 3. Okay? Then expanding 3x minus 4 squared, that would be 9x squared minus 24x plus 16. And we still have here minus 3, and we have here minus 3. 16 minus 3, that is equal to 13. Our g of f is equal to 9x squared minus 24x plus 13. Okay? Let us have example number 10. If f of x is equal to 5x plus 2 and g of x is equal to x cubed minus 4, evaluate letter A, f of g of 2, and letter B, g of f of negative 1. How do we solve for this? Letter A, f of g of 2 is equal to f of g of 2. G of 2 is inside the function f. Okay, we will first evaluate g of 2. Okay, to evaluate g of 2, we need to substitute 2 in x cubed minus 4. That would be g of 2 is equal to 2 cubed minus 4. G of 2 is equal to 8 minus 4. That is 4. G of 2 is equal to 4. So we can say that f of g of 2 is just the same as f of 4. Okay? And then the next thing that we need to do is to evaluate f of 4. For us to do that, we just need to plug in 4 in f of x equals 5x plus 2. That would be 5 times 4 plus 2. That is equal to 22. F of g of 2 is equal to 22. Alright? Next, for letter B, g of f of negative 1 is equal to g of f of negative 1. F of negative 1 is inside the function g. We need first to evaluate f of negative 1. And to do that, we need to plug in negative 1 in 5x plus 2. That would be f of negative 1 is equal to 5 times negative 1 plus 2. F of negative 1 is equal to negative 3. Since f of negative 1 is equal to negative 3, we can say that g of f of negative 1 is just the same as g of negative 3. To evaluate g of negative 3, we need to substitute or plug in negative 3 in x cubed minus 4. Okay, that would be g of negative 3 is equal to negative 3 cubed minus 4. Okay, g of negative 3 would be negative 3 cubed, that's negative 27, then minus 4, we will have negative 31. G of f of negative 1 is equal to negative 31. Okay? And that's it for this session. Let us check what we have learned. In this session, we were able to review the operations on algebraic expression. We were able to perform addition, subtraction, multiplication, and division of functions. And we were also able to simplify and evaluate function compositions. I hope that you've learned something from this session. In our next video, still under Introduction to Functions, we will be focusing more on solving problems involving functions. For more related practice problems, you may use our QuexBook General Mathematics app available from Google Play Store and answer Chapter 1.